Welcome. In this video I'm going to show you how you can obtain different measures of quantitative variation, including variance and standard deviation, using Microsoft Excel. I actually have a separate video where I use my own add-in, which actually simply has a function that can calculate it for all these different measures for you. But if you don't want to use that, it can be done without. For the standard deviation, Excel actually has a built-in function called standarddef.s, and you can simply specify the data and it will simply calculate it for you. If you want the population version, similarly, but then .p. The difference here is that this divides by the sample size -1 and this divides by the sample size. As you can see over here, it's actually the square root of the variance. And the variance is the average squared difference with the mean. So it's the average of every score minus the mean squared. So for the sample version, there's a var.s, and for the population, there's a var.p. Now, if you don't want to square the results, but you want to take the absolute values, this can be done by first calculating the average, which is just the mean, the average function. And then we have to subtract from every score. So over here, I'm actually doing this. It first checks if it's not empty, and then it takes the absolute value, because we have these pipes here, of the score minus that average. Note I've placed dollar signs here because when I copy paste it down, I don't want it to change. You can toggle actually with F4 to do this. The dollar sign in front of the row number fixes the row number, and in front of the column letter the column. I'm also using an Excel version where I have to separate parameters with a semicolon. In your case, it might just be a comma. All right, and then once we've done that, we can actually just take the average of all of those to get the mean absolute deviation. There are many actually that are abbreviated to MAD, so be careful if you see MAD which one is actually meant. Because sometimes they might actually mean the mean absolute deviation from the median. So that's very similar. We just determine the median first using Excel's median function, and then we use the same thing as earlier, but now we actually we subtract the median from each value, and then take the absolute value of that. So here it should be the mean minus the median, and that gives us that result. So this is actually x minus median, just to make things correct here. All right, and then we take again the average of those, and that gives us the mean absolute deviation from the median. You could also take the median of those absolute deviations from the median. So we can also just say, well, I want the median of all of that. The next two actually deal with deciles. So those are special versions of quantiles. There are a lot of different ways of actually obtaining these. I have a whole separate video on that, so check my video on quantiles if you're really interested in this. But for this video, I'll simply use Excel's built-in percentile inclusive method. And I've listed all the 9 deciles that are possible. There are just percentiles in tens. And then, so from my column A, I want this percentile, and now I have all of the 9 percentiles. I actually need the average of this, and that's being done here. And then we need to actually subtract the decile from each of the scores, and decile mean, sorry, and then take the square of that. So what's being done over here is it takes the value, then minus the decile mean, that's all the way over here, and last it then squares the result. All right, then it's actually similar as with the normal variance. We sum all of that up, divide by the sample size -1, and then take the square root. So The sample size is simply obtained by using count. And yeah, that's my count. And then the standard deviation decile mean is the sum of all of those divided by the sample size minus 1 and the square root of it. Alright, the coefficient of diversity is then taking this value and dividing it by the decile mean. So that's fairly straightforward and is actually the alternative for a more popular version, which is the coefficient of variation, which is the standard deviation divided by the mean. So we calculate the mean of all the scores. That's from column A. We actually did that already earlier. And divide the standard deviation that we calculated earlier by this mean. The advantage of the coefficient of variation is that it rescales kind of the standard deviation, and then it makes it easier to compare it with other standard deviations. Alright, I hope this video was helpful, and thank you for watching.